Hi everyone, welcome to Maths for Week 5, Year 5. This is Lesson 1 and today we're going to be looking at 24-hour time. So all this week is all about time. So firstly, what we're learning to do today is to read and use 24-hour time. So to do this, you'll need to be able to recognize and read 24-hour time on a digital clock, identify situations where 24-hour time is used, and convert between 12-hour and 24-hour time. Now let's start by looking at this clock. So what's the time on this clock? Well, this is an analog clock, so it has an hour hand here and a minute hand, and we can distinguish those by knowing that the hour hand is shorter and the minute hand is usually thinner and longer. So our hour hand is pointing to 10, and our minute hand is pointing to 5, 10. So each of these numbers here are intervals of 5 minutes, but they also represent the hours. So this is our analog clock. So the time on this clock would be 10 minutes past 10 or 10:10. Now I want you to think, what time of day is this? Is this the morning or is it the evening? Yeah, you can't actually tell on this clock because it's an analog clock. It doesn't tell us whether it's AM, which is before midday, or PM, which is after midday. So this is our 12-hour clock. It's split into 12 hours as we go around here. But to know whether it's in the afternoon or in the morning, we need to know whether it's AM or PM, and this kind of clock's not going to tell us. So here we've got a digital clock. This was a slightly different time. This is 10:06 AM in the morning. Yep, so the digital clock here would need to have this AM, or down here it'd probably go PM. Now, what about this kind of clock? So instead of having 12 hours, we've got 24 hours. And this kind of clock seems to make more sense in that we know that there are 24 hours in one day. So we'd start here at 24, and this would be midnight. Yep. And you can see here on this clock, that's sort of right in the middle of this dark section here. And then opposite to that, we've got 12 o'clock, which is midday. And going around, instead of having intervals of 12 hours, we now have 24 intervals for 24 hours. So now that we've looked at an analog clock with 24 hours on it, let's compare 24-hour time and 12-hour time, or PM and AM time. So here, 12 AM, which is midnight, in 24-hour time, it would be 0 hours, yep. Then 1 AM is 1, 2, and so on until we get to 1 PM. Now, instead of going to 1 here, because this jumps from 12 PM to 1 PM, we just keep on counting up. So we go 12, 13, 14, 15, all the way to 23, which is 11 PM, 11 o'clock at night. So with 12-hour time, we use these abbreviations AM, which is actually in Latin for ante-meridiem, which means before midday. So ante here means before. And then we've got PM, which means post-meridiem. So post means after, so after midday. So that's how we distinguish in 12-hour time, whether it's in the morning or in the afternoon. With 24-hour time, we don't have the AM and PM. We don't need to have that because we just have 24 hours. So if it's 13 hours, we know we're in the PM, or if it's 12 hours, we know we're in the PM. Anything before that, it's in the AM. So why are we having this discussion about 24-hour time when we've already got a 12-hour time with AM and PM that seems to work well enough for us? Well, there are a lot of advantages to 24-hour time. So for example, let's say something happens at 2:15 p.m. in the afternoon. And in 24-hour time, you would record that as 14:15, and you don't need the PM or the AM there. But recording it this way is completely unambiguous. You're not going to mistake this for an A, like an AM. So immediately you see the 14:15 and you know that this is in the afternoon. Whereas when you have 2:15 AM or 2:15 PM, there's a chance that you might not see this small suffix at the end, and you might mistake it, oh, this is 2:15 AM. Now, this is really important in situations in the military where you need to be very precise about the time. Same in medicine or in hospitals. This type of time, the 24-hour time, is used because it's unambiguous. There's no way of getting it wrong. Likewise, in science as well, we need to be precise when we're recording findings or measurements. So 24-hour time, this one here would be the preferred one. Another situation as well, so there's lots of different situations, is in transport. So if you're catching a train or a flight or a bus even, you need to know the exact time, particularly for flights, because you're obviously paying a lot. And also, flights happen at all times of the day. So here we've got this flight going to Stockholm, and it's happening at 13:10, which is 1:10 p.m. Something I was actually surprised to learn is that most countries in the world use 24-hour time. There's a small selection of countries, Australia being one of them, where the 12-hour time, so the AM and PM time, is used. But the majority of the world actually uses 24-hour time. So a lot of Europe, South America, Asia, 24-hour time is the preferred way of recording time. And I came across this really interesting example in Japan. They actually extend it beyond 24-hour time. So you can have situations where you have 2,500 hours, which means it's actually 1 a.m. the next day. But this is just for shoppers, so it's nice and easy for them to know that this time here extends beyond 10 a.m. in the morning. It goes actually into the next day. So it's kind of a unique thing just for Japan, but I kind of came across it, I thought it was quite interesting. This picture down here is also another fascinating example of why 24-hour time is useful. This is a Russian watch, and it's used by Arctic explorers or scientists, and it has the 24 hours going around. Now, it's really important for them to know, what the time is while they're up in the Arctic Circle, because during winter or summer, the days can be extremely long or they can be extremely short. So there can be a lot of darkness or a lot of light. It can actually be really hard to distinguish, are we in the afternoon or are we in the morning? It's quite easy for us usually. We know it's sort of midday compared to midnight because the sun is in the sky. But in the Arctic Circle, you can have like a midnight where the sun is still up because of the axial tilt of the Earth. So I thought that's quite an interesting example. So there's lots of different uses for 24-hour time. Is a very important way of recording time, particularly if you'd like to travel or go into science or into medicine or the military. These are all practical applications for 24-hour time. If you ever catch a flight or any other form of transport, 24-hour time will also be used. All right, so now we know we've got two ways of representing time in a day. We've got our 12-hour system, which is the one that we more commonly use in Australia, which is our AM and PM time. And we've got our 24-hour time, which is used internationally in medicine, in the military, in science, and in transport. So there'll be situations where we need to convert between the two of them. So let's start with converting from 12-hour time to 24-hour time. And let's start in the morning. So if our time ends in AM, so it means it's in the morning, we've got 9:35 AM here. There's only two steps we need to follow. We remove the AM because we know with 24-hour time you don't need AM and PM. And if it's only one digit, like in the hour time, so here we've got 9, we need to add a 0 to the beginning. So our time becomes 0935. With PM time, so we've got a time in the afternoon or the evening, 6:15 PM, we remove the PM again, and you need to add 12 hours, because instead of just having 12 hours, like 2 lots of 12 hours, we actually now have 24 hours. So you just need to add 12 hours. So 6:15 PM, we add the 12 hours, we only change the hours part, and it becomes 18:15. Now let's do the other way around, 24-hour time to 12-hour time over here. So if our time is less than 1200 hours, so when you've got 00 like this in the minutes, we say 100 hours, so it'd be 1200 hours or 700 hours or it's like 300 hours. Or actually here you could say 0700 because it's got a 0 at the front. So if it's less than 1200 hours, we add the AM because we know that it's in the morning. It's before midday. This is midday in 24-hour time. So we add the AM because now we're going into 12-hour time. So we need our AM and PM, and we remove the 0. You don't need a 0 in front for AM and PM time. If you had it there, it's not terrible, but it kind of makes it look almost like 24-hour time. So it's kind of good practice not to have it. You'll see it on a digital clock if it's got AM and PM. But if we're just writing it, maybe on a piece of paper or in a document, this format is the way to go. So it just comes to 7 AM. If our time is greater than 1200 hours, so now we've got 1445, what we need to do is we need to subtract 12 hours. So it's kind of the reverse of this one down here. Yep, so this is changing it to 24-hour. Here we want to bring it back to 12-hour time. So when the number is larger than 12, like here we've got 14, we need to subtract 12 hours. And we only do that from the hours part. The minutes in these stay the same. Minutes are completely unaffected. We're just worrying about the hours. So we subtract 12 from 14, it gets 2. We put the minutes part back, so it's 2:45. And because it's greater, it's larger than 1200 hours, it's going to be in the afternoon or the evening. So we add the PM. So it becomes 2:45 PM. So if you've got 12-hour time, you absolutely have to have the AM or PM. And with 24-hour time, you don't need to have that, but you do need to have a 0 where it's a single digit like this. Now, this is probably just a good thing to remember. And this is probably the area that people get caught up in the most, because some people go, oh yeah, I know like 1400 hours is 2 p.m. But it's this thing about midnight and midday. So already this is a nice easy conversion here for midday. 12 p.m. is 1200 hours. Midnight is a little bit trickier. So midnight in a 12-hour clock, 12 a.m. is midnight. Now it sounds a little bit strange because you think midnight, it's nighttime, and a.m. is kind of like the morning. But it's 12 a.m. is midnight in 12-hour time. But in 24-hour time, even though we say we've got 24 hours, once you get to 24, you're actually in a new day. So this is the earliest time of a new day in 12-hour time. And this is the earliest time you can possibly have in a 24-hour time. So it's the latest time you could have would be 23, if we're just going to the minutes, 23:59. Once it ticks over one more minute, it's into a new day. So we're starting over again and we're at 0 hours, which is here. Yeah. So this is really useful to remember this part. I can't really think of a quick rule for it. These other ones, the other conversions, you can use these rules. This one, particularly the 0 hours, you just need to know it. And this is probably the biggest pitfall that people will get caught up in. They're like, oh, yep, yeah, 1200 hours, yep, that's midnight because I know that 12 o'clock is midnight, 12 p.m. is midnight. It's not in 24-hour time. 0 hours, that's the stroke of midnight, that's going into a new day. So let's do a few conversions before I can send you off to do your own activities today. So we've got 12 hours to 24-hour time. So let's start with 3 a.m. So I know with 24-hour time, I don't need the AM. I know that it needs a 0 here at the front. And I know because this is in the morning, I don't need to add 12 hours. So it's 0, 300 or 300 hours, 0, 300 hours. Here I've got 9:35 p.m. So I remove the PM, and I know because it's in the evening, it's after midday, I need to add 12 hours. So I add 12 to 9, which is 17, and it becomes 17:35. And lastly, we've got 11:06 p.m. So again, I don't need the PM for 24-hour time, but because this is in the PM, it's in the afternoon, I need to add 12 hours again. So 11 plus 12 is going to be 23:06. The minutes stay the same. So we're getting very close to midnight here, or 0-100 hours. And now we're going to do the inverse or the opposite. We're doing 24-hour time to 12-hour time. So here I've got 0 for 15. Now I know because this is less than 1200 hours, it's in the AM. So I'm attacking an AM, it's in the morning, and I don't need this 0 here. If I had the 0, it's not completely incorrect, but you can scratch the 0 off. Here I've got 1300 hours because it's greater than 1200 hours. I'll go to B over here. I know it's in the PM because 1200 hours is 12 PM. And I need to subtract 12 hours as well. So scratch that off. 13 minus 12 is 1 p.m. So it's 1 p.m. or 1 in the afternoon. And lastly, 21:55. Again, it's greater than 1200 hours, so it's in the evening. So I add my PM because it's after midday, post meridian, and I take away 12 again. So that's 21 take away 12 is 9. So it's 9:55 p.m. or 9:55 in the evening, and it's that simple. Now, when you're doing your activities, if you need to refer to these rules again, that's totally fine. There's a great tool which I'll provide a link for in the classroom feed, which has this time tools activity or game. It's just a good way of actually practicing reading different clocks. So here you're reading a analog clock, and then representing this time in 12-hour time on a digital clock and in 24-hour time on a digital clock. So you're kind of using all your time reading skills here, essentially. It's a great way to kind of practice getting really familiar with all those skills. Okay, so it's a little bit of a longer lesson again today, mainly because 24-hour time, you'll be seeing it all week, and it's quite an important concept to cover. So here are the main ideas. 24 hours shows the amount of hours and minutes that have passed since midnight. So remember, midnight is 0-100 hours, and the latest time to the minute we can have in 24-hour time is 23:59. As soon as we add another minute there, it doesn't actually go to 2400, it goes to 0-100. Unlike 12-hour time, you don't need the AM and PM for 24-hour time because it already tells you here, I already know this is in the evening, it's in the PM because it's greater than 1200 hours. 24-hour time is used in most countries, the military, travel, and also medicine. I didn't write that. And we can convert between 12-hour and 24-hour time. We need to know that there are two different systems and also how to do it. And we've kind of covered that before. If you need lots of practice, refer back to these slides. Otherwise, you get plenty of practice this week. Okay, hopefully a shorter lesson tomorrow. Good luck, guys, and I'll see you in lesson 2. All right, welcome to lesson 2 for week 5. This is on time zones today. So in lesson 2 today, we are learning to compare time zones in various zones or various places in Australia. To do this, you need to be able to recognize different parts of the world and different parts of Australia have different time zones. So we'll look at that in a minute. You'll need to be able to calculate the difference between different time zones in Australia and understand how daylight savings time affects the time. Before we start talking about time zones, it's really important to recognize that the Earth, half of the Earth at any given time, is actually covered in shadow. So we know that, and hopefully you'll have learned this from science, that we know that the Earth is a sphere and it orbits the sun. As it's orbiting the sun, as it's going around the sun, it's also spinning. And it does one complete rotation roughly in 24 hours. That's why we have a 24-hour clock, essentially. And we looked at that yesterday. But because the sun is over here, giving off all its sun rays, those rays are only hitting one side of the Earth. So this other side here is in shadow. Now you can see the stars and stuff here. This is what we know as nighttime. Yeah. So while we're here, let's say we're over here. I can't even recognize where this is on the map. Let's say we're here and it's 4 p.m. here. It might be 8 a.m. over here. Now, while these people over in this country here are experiencing 8 a.m., we're experiencing 4 p.m. And it's happening at the same time. And we'll look at how that can actually happen in a second. Okay, so how can two places in the world at the very same point in time have different times, or be operating under different times? Well, it works based on this system of time zones. So we know that this part up here is north. Let me just write it up here. And this part here is south. So we're in the southern hemisphere. This is our equator. And you'll see here we've got these different colored strips. So these different kind of vertical lines of longitude. And it splits the world into 24 different sections. So the way we count time across the world, and depending on the way we kind of organize, which part of the world is in which time zone, starts at this point here, which is called this kind of thin red line here, the international date line. So countries that are here, like New Zealand, these Pacific Island countries, they are operating 2 hours ahead of where we are in Sydney. So let's say here it is 5 p.m., which is 5 p.m. while I'm recording. In New Zealand, it will be 7 p.m. So we're in Sydney here, it's 5 p.m. Meanwhile, if I skip ahead another 2 time zones, or let's actually go 3 time zones, make it a bit interesting. 1, 2, 3 to this red one here. They're going to be 3 hours behind us. So they're going to be at 2 p.m. and so on. So you can actually have a situation where on the other side of the world, so now it's 7 p.m. on the 6th of August. If you're in England, that's where my brother is, it's actually, I think it's about to go 8 a.m. there. And you can even have a situation where people are still on the previous day because of these time zones. Actually, there would be people at some place, probably maybe even America, maybe, where they're still operating on the previous day because of the way the world is split into 24 different time zones. So that's kind of roughly the time zones. I'm not going to go into too much detail. These colors here, they're actually called irregular time zones. Now we have one in Australia here, which we'll get to in a moment. China has an interesting time zone, just it doesn't actually split it up. So China is a big country, but within China, it operates under the one time zone. So it can be 9 a.m. in, let's say, Shanghai here, and then all the way on this border here on the western border, it can also be 9 a.m. So they kind of deal with that. It's quite interesting. There's actually 3 different time zones in China, but they all operate under the one time zone. So that's time zones at a world level. Now, I don't expect you to understand how to calculate between all these. It's quite tricky. You can see it goes around certain countries. It cuts through certain countries. It really just depends. It's not like here on this bit here, and it goes around this country. Obviously, they want to be within the same time zone as the UK. And also remember that the globe is curved, so this flat map representation isn't entirely accurate. So here, a great way to figure out time zones as well, if you have to, is to use like either a clock or a watch, or a smartwatch or a website. This is a great one, time and date. So you can see here in New York, it's Friday there when I recorded this or took this screenshot, but it was 2:40 a.m. here. Whereas in Sydney, when I took the screenshot, it was 4:40 p.m. Okay, so we know the world has different time zones. There are 24 of them roughly. They start from the international dateline, which is here, which is over in New Zealand. Countries that are to the west of the international dateline, so this way, will be ahead of countries that are to the east of it. So here, let's say you're in Hawaii, which is all the way up here. That's kind of the furthest time zone, so it'll be almost 24 hours behind that kind of New Zealand time zone. Now, I don't expect you to know all the different time zones around the world. There are a lot of them. Most people just look it up on a phone to make that calculation. I only need you to worry about the 3 different time zones in Australia, the 3 standard time zones we have. So let's think about Sydney. We're in Sydney here. We are in the Australian Eastern Standard Time zone. In this yellow section here, Alice Springs, Darwin, Adelaide, they are in Australian Central Standard Time. And Western Australia, well, what's the opposite of East? It's West, Australian Western Standard Time. Okay, so what's the difference between them? Well, you would think it's an hour. So here we've got 1, 2. So Australian Western Standard Time would be 2 hours behind Australian Eastern Standard Time. So let's say here it's 5 p.m. In Perth in Western Australia, it's going to be 5 minus 2. It's going to be 3 p.m. It's 2 hours behind the Eastern Standard Time. Now, I wish things were nice and simple, but to make things a little bit more confusing, this yellow time zone, Australian Central Standard Time, they felt that an hour difference between Australian Eastern Standard Time was too much. So instead of having an hour difference, it's only half-hour difference. So while it's 5:30 in Australian Eastern Standard Time, it's going to be half an hour behind that, which is 4:30 p.m. Now, Australia is not the only country where we have these interesting time zone situations, but it's really important to make that distinction. So here we've got our 3 time zones: Australian Eastern Standard Time, Australian Central Standard Time, and Australian Western Standard Time. You know, I only use those abbreviations because obviously it's quite a mouthful. Okay, so that's our standard time zones. Now you might be wondering why I'm talking about standard time zones. Well, we have daylight savings time. Now you guys might be aware of this. In the summertime in Australia, in certain states and territories, we observe what's called daylight savings time. And this is where we actually bring the clock forward an hour. So instead of being 2 p.m., or it's actually 2 a.m. in the morning, it changes. Instead of being recognizing 2 a.m., people wind their clocks or set their clocks an hour ahead. So you're actually going to lose an hour. But the reason we do this is that you get more daylight hours in the day. So you get more sunshine, more daylight. If you move the clock forward an hour in those states, what happens is because the Earth is on an axis, is on a tilt, we know that we get the seasons. But in summertime, in the southern hemisphere, at least for us, when we have our summertime, we're getting more sunlight. So we try to optimize that, try to get the best out of it by moving our clock forward an hour. That means while people are up and about and going about their daily business, they'll kind of get more daylight hours. What happens in the summertime if you don't do that, in certain areas, you end up getting a lot of daylight in the morning. And you kind of notice this, the closer you get to October, you realize like it's so bright, it's so light early in the morning. So that's why we kind of move it forward an hour. In winter time, we take it back an hour. So this is, once we take it back an hour, we are out of daylight savings time. And I say we're kind of going into the dark times now. You'll notice that it gets darker earlier in the afternoon, whereas compared to daylight savings time, it can be like 8 p.m. at night and it's still sunshine out. Yep. So that's daylight savings time. How does that affect our time zones though? Well, I wish it was nice and simple, but it's a little bit complicated. This is actually taken from a newspaper. This shows the kind of differences between the different states and territories. Some states like Queensland, Northern Territory, and Western Australia don't actually observe daylight savings time. So they don't change their clocks. Their clocks are the same all year round. States like New South Wales, Tasmania, ACT, and South Australia do observe it. Now, that kind of doesn't break our time zone system, but it does add an extra level of complexity to it. I found this diagram, and this actually kind of shows a great, it's quite useful to distinguish between the different time zones. So let's say the time in the Australian Eastern Standard Time is 10 a.m. But we're in daylight savings time, so we actually write DST when we're in daylight savings time. So you might be Australian daylight savings time. Now, Queensland doesn't observe daylight savings time, so they're just ticking along, 10 a.m., everything's all good. South of the border in New South Wales, Victoria, ACT, and Tasmania, we are observing daylight savings time. So we've pushed our clock forward an hour. So instead of being 10 a.m., it's now 11 a.m. So there's a difference of an hour. We know that in Australian Central Standard Time, they're half an hour ahead, so they're 0.5 of an hour ahead. Northern Territory doesn't observe daylight savings time, so they're just half an hour ahead of Queensland. But South Australia does observe daylight savings time, so they're half an hour ahead of these states down here that are observing daylight savings time. And good old WA over here, no daylight savings time there, but because these eastern states here have daylight savings time, there's actually a 3-hour difference now instead of just our regular 2-hour difference. So I've included this map on your activities today. It'll be a little bit tricky. You'll need to obviously know your geography, where the different cities are in which states and territories. But hopefully you can use it to figure out the difference. So here, let's say the difference was Hobart, which is down here. That should be a capital H for Hobart. I'm going to rub that out, that's too messy. Hobart down here, and we're talking about Brisbane up here. Yep, there's going to be a difference of 1 hour. So let's say the time in Hobart is 9 a.m. Well, we know that Hobart's 1 hour ahead of Brisbane, so the time in Brisbane will be 8 a.m. And you'll be doing that on a table, but you'll have this map here to help you. So here are our main points from today. Australia has 3 major time zones: the Eastern Standard Time, the Central Standard Time, and the Western Standard Time. Central Standard Time is a little bit trickier because it's half an hour behind Eastern Standard Time rather than usual kind of hour behind like most time zones. Australia has daylight savings time, and different states and territories observe daylight savings time. Those that do, so that means they do it, so they do a daylight savings time. In October, they move their clock forward an hour. So 2 p.m. or 2 a.m. becomes 3 p.m. or 3 a.m. So you effectively lose an hour in the day. You kind of lose an hour's worth of sleep. You have to get up earlier. But in April, when you're going in the autumn time, kind of going into the winter months, the time goes back. So you actually gain an hour. So let's say you're at 2 p.m., the time goes back an hour to 1 p.m. So you're actually gaining an hour in the day. And that means that it kind of resets the sort of time, the standard times that we have, and it kind of affects the daylight hours in terms of how much sunlight you're getting at a certain time in the day. All right, guys, good luck with the time zones activities for today. I know it's quite confusing. Please use the map. Refer back to this presentation if you need to. It can be quite tricky making those conversions, but the main thing is that you're aware of them and you can compare them. So good luck with it today. I'll see you in lesson 3.
Okay, welcome to lesson 3 for Wednesday, week 5 for year 5. Today we're going to be talking about appropriate units for measuring periods of time. Okay, so today we are learning to select appropriate units to measure a period of time. Now this word here, appropriate, really means is it the right type of unit in that given situation. So at school we sometimes talk about appropriate behavior. Is it the right behavior, for example, to have in the classroom? Here we're saying, is this the best unit or the most appropriate, the right unit for measuring a certain period of time? To do that, you'll need to be able to recognize units for measuring periods of time, so know which ones are available to us. Select the most appropriate unit for measuring a period of time, and convert between units of time. So on Monday and Tuesday, we looked at, what's the time in the day or in the evening. That's kind of looking at time as in terms of representing a certain point of time. Today, we're looking at measuring a period of time. So how long it takes to do something, the duration of an event. So let's look at some of our common units of time that are available to us. Now, hopefully you're familiar with some of these. We're sort of starting with the smallest ones at the top and then working all our way down to some of the larger units of time. Obviously, they get bigger than that as well. But these are the ones we're really concerned with for today. So firstly, 1 minute equals 60 seconds. 60 minutes equals 1 hour. So we've got that 60-60 going on here. Then we know, as we covered on Monday, Tuesday, we've got 24 hours in a day. And then 7 days in a week. And I'll just stop there. Now, knowing these units, these kind of conversions is really useful when you're going, well, how should I represent this amount of time? So for example, say something takes 7 days. Would you say it took me 7 days, or it took a week? Or if it took 120 minutes, that's also equivalent to 2 hours. So it's sort of like, well, both are correct, but which one's probably the easiest for somebody else to understand, the most appropriate in that situation? Now, sometimes with something like a movie, for example, they might have a runtime of, let's say 80 minutes. So really they're saying it's an hour and 20 minutes. You can also combine these as well, which we'll have a look at in a minute. Working down the table, we get to a month. Now, months aren't exactly 4 weeks. They're not all 28 days, except for February, kind of standard non-leap year. But we roughly say, a month takes about 4 weeks. So if someone says, oh yeah, it took about a month, most people would think, yeah, it's about 4 weeks. That's what I'm working off. But we know that months can be 31 days, 30 days, and February 28 or 29 days. A year is 52 weeks or 12 months. And then 1 year is also 365 days, and in a leap year, it's 366. So if, for example, you're recording something in days, if you really need to make it precise, so it's like, it took me 367 days, and you need to be very precise about that, then sure, writing 367 days would be fine. But if you're talking in more general terms, then you probably just say a year, because we know that there are 365 days in a year. 367 is pretty close to 365. So you probably say a year if you're being general. So it's also a matter of judgment. It's not a saying, oh, these are the set rules. You have to measure this in days, or you have to measure this in years. No, there's no rules like that. It's more a matter of, is this appropriate? Is this easy for somebody else to understand? And also, how precise do I have to be? So let's look at some examples. So firstly, we've got this person here taking a shower. Now, roughly with a shower, you'd probably be recording that in minutes. Most people don't take a shower in seconds, unless it's like an ice cold shower and it's less than a minute, in which case you might record it in seconds. But if it's more than a minute, which most people generally have a shower for more than a minute to get clean, you'd be recording in minutes. If it was an hour-long shower, then they're obviously having a very long shower. But in most situations, you'd be recording in minutes. I might put it min. Here, doing logging into your computer, typing in your login credentials, your password, and your username probably takes about seconds. Hopefully, might be 1 second if it's already all saved like that, and you can just tap enter. Getting a university degree or graduating from high school, that process of getting it, so obviously the graduation might take maybe an hour or two, but the actual process of completing that qualification would take years. So here we need to be you wouldn't say, oh, it took me, I don't know, trying to convert that into years and into days, like that many days, you'd probably use years. You'd say, oh yeah, it took me about 5 years, rather than, oh, it took me 15,000 days or something like that. Here, someone's broken their leg. Now this is a situation where it might be weeks or it might be months. Depends on how specific you want to be. You could say, oh yeah, before my cast came off, it was 1.5 months. Or yeah, I have to have my cast on for 6 weeks. So that's a situation where you'd use some judgment, and it also kind of changes. It changes how generally you can speak about both of them. It's roughly the same thing, but it's sort of like, oh yes, weeks is more specific than months. Catching a flight, most flights last about an hour or so. Here's a kind of 747, so obviously it's going somewhere far away. A short flight might take 40 minutes, 30 minutes if you're only flying to maybe Canberra, but if you're flying to maybe Melbourne or overseas, when we can fly again, you'd probably be recording that in hours. But again, you'd need to know the specifics of the flight. There's no general rules. You wouldn't be recording it in seconds, though. You could record it in seconds if you wanted to be really precise about when you took off and when you touched down. But it's more appropriate to use hours or minutes because it's easier to communicate that to somebody and for somebody else to understand. And also, you're talking about smaller numbers. Here, you've got a microwave, you're heating up something. You probably take about either seconds or minutes, depends on how hot or cold the food is. So if it's coming from the freezer, it might take minutes. And if it's from the fridge, might be seconds. We've got 2 people running a race here. So this one is 100 meters. So doing a 100 meters sprint would be recorded in seconds. Most people could finish that within seconds. Even if it was greater than a minute for whatever reason, probably we're recording in seconds. Here, some marathons, so that's 42 kilometers. Apparently, if you run a marathon in 5 hours, you're actually doing quite well. So you probably were recording that in hours. But if you wanted to be more specific about it, then you could maybe add minutes as well. And if it was really close, so the first and second place were really close and one person just missed out, you might even add seconds. So you might be recording in hours, minutes, and seconds. A drive from Melbourne to Darwin, it can take so many hours. I think it's the time, a quick Google, was 40 hours. But if you want it to be more, I think that's non-stop as well. If you want it to be more general, you might record it in days. It's like, oh yeah, it took us 2 days or 3 days or 2.5 days. Depends on how much driving you do as well and how specific you want to be. And lastly, I touched on this before, a movie runtimes are usually recorded in minutes. So they might say, yeah, this movie goes for 120 minutes, which would be 1.5 hours. No, not 1.5 hours. It would be 2 hours, apologies. Or I might say kids movie maybe go for more like 80 minutes. So 1 hour and 20 minutes. You could say, oh, it goes for 2 hours. Yeah, movie goes for 2 hours. Or if you want to be really specific, you use minutes. So these are situations where there's no one specific rule. You need to use your judgment. And also it changes the precision, how precise that recording of time is. So again, back to this marathon example, you could have hours, which is quite general, but you could have hours and minutes, which is more specific, and hours and minutes and seconds is very precise in terms of going, well, this is down to the second. All right, so the last thing we're going to do today is record some of these periods of time using the units of time, using the most appropriate one. So we spoke about the sprinter running 100 meters. And we thought, well, probably for that event, seconds would be the most appropriate unit of time. So let's say this person runs in 12 seconds. So I just record it like this. Let's fix up these. Now you'll see here, I didn't just write 12. With any form of measurement, whether that's length, area, volume, mass, I always have to specify the unit of measurement. So here it's seconds, so it's 12 seconds. Now you might go, Mr. Kilpatrick, someone's not going to take 12 minutes to run 100 meters. So 12, it's going to be 12 seconds. You always have to put the unit of measurement on there. It needs to be completely unambiguous. Nobody can get it mistaken and go, well, actually, maybe they were very slow, or maybe they stopped halfway and had a rest. It has to be completely unambiguous, so you need to specify the unit of measurement. Let's look at our marathon runner, 42 kilometers. Let's say they take 5 hours, so I'm going to write 5 first, because I'm going to start with the largest unit of time. This is the same way you would say it. You wouldn't say this person ran 40 minutes, 5 hours, and 2 seconds. We always start with the largest unit of time first. Similar to how we're saying a number with place value. We say 5 hours, 40 minutes, and let's say 7 seconds. Now I could just say they ran 5 hours, or I could say, oh, they ran about 6 hours. But here, I want to be really precise about it because this person was beaten by 2 seconds by somebody else. So that person ran 5 hours, 40 minutes, and 5 seconds, so 2 seconds less. So in that situation, or this person takes their running very seriously, I want to be very precise. I'm going to use all 3 of these units of time. You could even be more specific and do hundredths of a second, which we'll look at tomorrow. But this is how you'd record it using hours, minutes, and seconds. I can also do it this way as well. 5.40 for 40. .07. And here I need to also be very precise as well. So some people might go, well, is this 5 minutes or 5 seconds? So what I like to do down the bottom is to write hours, minutes, and seconds there as well. So nobody can mistake that. Nobody goes, oh, okay, well, this is actually 5H, 5 hours, or 5HRS, maybe, if you want to be even more precise. So that's it, using that form of notation. Now you might think, oh, well, actually, I can do this with decimals as well. So I'm going to write 5.40 hours. Now these two things, you can write time using decimals. but 5.4 hours isn't the same as 5 hours and 40 minutes. That's because there are only 60 minutes in an hour. So what this is actually telling me, because I'm using decimal notation, this is saying basically 40% here of 1 hour, which is 24 minutes. So it's not actually the same as 5 hours and 40 minutes. So you need to, if you're going to use decimal notation, you need to do a conversion, which we're not going to look at today. But I just want you to be aware of that. So don't think, oh, I can just do, yeah, 5.4 hours and that's it. You know, it's 5 hours and 40 minutes. It's not the same. Okay, so that brings us to the end of the lesson. The main ideas from today. When you're selecting the most appropriate unit of time or most appropriate units, this is really a matter for your own judgment. You need to think about the situation, think a bit critically about it, go, well, what's the most precise? What's the one that's going to make sense to most people? You know, I could record somebody running 100 meters using, you know, hours, but I wouldn't really do that because it only takes seconds. So I could use a decimal, you know, 0.0 whatever of an hour, but it doesn't really make any sense. So in that situation, I'm going to use seconds. So it really relies on your judgment or common sense. The unit you select can change how precise the measurement is. So we looked at making that marathon runner and their recording quite precise using hours, minutes, and seconds. Knowing your conversions can help you select the most appropriate unit. So with our example of the week, we know that there's 7 days in a week. So instead of saying 7 days, you could just probably switch to 1 week. You can use a combination of units to measure a period of time, which we looked at just then. Always write the unit of time after the measurement. This is so important for any measurement activity we ever do or you ever do in real life. And lastly, when written, units of time start with the largest unit and go to the smallest unit. So 4 hours, 30 minutes, and 28 seconds here. I'm actually going to switch this to hours, min, and seconds there. Yep, starting from big, going to small. Okay, thank you for your time today, everybody. I'll see you in lesson 4. Welcome back, everybody. This is week 5, lesson 4, Thursday for year 5. Today, we're looking at recording duration of events. So today, you're going to be recording the duration of an activity. That's how long it takes to complete an activity. You're going to be using a stopwatch to measure how long it takes to do the activity. So it's a duration. You're going to be using minutes, seconds, and this new unit of time today we're going to look at is hundredths of a second. And lastly, you're going to order the times based on how long it took to complete them. So it could be from shortest to largest, or shortest to longest, I should say, or longest to shortest amount of time. Okay. So firstly, on your Infinities or on your laptops or your tablet, or if you have a phone, you should have a stopwatch application. It's pretty common. And this is usually the way it's kind of presented in terms of when it's recording time. So here we've got our hours, and this person here, thankfully, or who designed the app, has put hours here, minutes here, and seconds here. So we know this is what we're dealing with. Now, yesterday I said, with units of time, you can measure with decimal notation, but you need to be careful because with minutes and seconds, there are 60 seconds in a minute and 60 minutes in an hour. So it doesn't translate across to saying, well, this is 1.04 minutes. That's not correct. It's 1 minute and 4 seconds. But this bit that's tacked on here, you can see there aren't the 2 dots between the numbers here. You've got a decimal point. And what this is telling us that this number here is actually hundredths of a second, because we know with our decimals that this is tenths and this is hundredths. Let's put a little th there, so no one's talking about tens. So this is 46 hundredths of a second. And you'll see on your stopwatch that this one goes up really fast, like it's just kind of just flits by. So here we actually have a combination of units of time, hours, minutes, and seconds. And then we also have this decimal notation, 0.464 hundredths. I'll just write that down, hundredths. I've got space of a second. So as a fraction, this would be 1/100th of a second. So if you cut a second into 100 pieces, that's one of them. So it's a very quick amount of time. But the reason why we have that is because it's very precise, particularly with, say you're running a race. It can get people can be so close that seconds aren't actually a small enough unit for it to be precise. So we go down into hundredths of a second. So using a stopwatch, quite simple. You'll start with all these zeros in all the different units of time. Always make sure you're starting from 0. So if you've previously recorded something, you might have in seconds here, you need to be seeing zeros across the board. So you probably, with this particular app, I just click this button here, and now I'm back to 0. Otherwise, you're going to be adding extra time on there. You don't really want that. The next thing you'll want to do is make sure that you record the time as it appears on the stopwatch. So not taking any shortcuts. Now today, I don't expect you to write hours, minutes, and seconds underneath. I assume most of them will start from minutes. So you should really only have 1, 2, 3, but you might also have hours. So for example, I think one of your events that you're recording or activities you're recording is tidying your room. If that takes you hours, then all your other times will also need to have hours at the front here. Now this time has only taken 1 minute and 3 seconds. So the hours is in 0. So if you're recording it today and one of your events takes an hour, let's say recording, cutting your room takes you 2 hours, you'd write 0 to ... and it took you 20 minutes and 4 seconds. So I'd write a 0 here, 4. And you really want it to be super precise, so you put it down to hundredths of a second and 52 seconds. Now, you'll see here, before these single digit numbers, I've always put a 0. So in each of these places, I guess you could call them, there needs to be 2 digits. You can't just skip it and go, okay. Actually, at the front, you might be able to, but certainly in between these two here, you can't just skip this and have a 4 because it might be a bit confusing. It's like, well, is this actually 40 seconds or is it 4 seconds? So make sure it's nice and clear. So here, as you'll see, basically record whatever you see on the stopwatch that goes into your table. What I've done on this slide is that I've ordered some activities from the shortest duration, so how long it takes to complete them, to the longest duration. And you can see here, I've got my table with the activity and the duration here, and I've actually specified hours, minutes, seconds, and hundredths of a second. And you'll see here, I've got the decimal point instead of the 2 dots because it's hundredths of a second. And then below, I've ordered them based on shortest to longest. So even though this activity only took 1 minute, 38 seconds, and 55 hundredths of a second, in this hours space, because some of these activities, or one of the activities took 2 hours, that was recording videos, I've decided to keep it consistent all the way through. So nobody gets mistaken, oh, is that 1 hour? Here we've got each of the different kind of places, hours, minutes, seconds, hundredths of a second. So for this space, where there's nothing going on there, I've put 2 zeros. Same here with the minutes place. I've got 1 minute, but because there's 60 minutes in an hour, I can have a 2-digit number in the minutes. So here I've just put a 0 as well. So nobody gets mistaken that, is it 10 minutes? It's definitely 1 minute. It seems a little bit tedious, but it's precise, particularly when you're dealing with stopwatches and recording times on stopwatches. Today, most of your things will take minutes, seconds, and hundredths of a second. But if they take an hour, you'll want to make sure you put that there. So going down, I'm just going to scroll down. These are all zeros until I get to 2 hours here. So this one's at the bottom. And this is also a great way of what's great about having them with the two places here, I can just kind of scroll down as I go here. So 7, 0, 0, etc. So here going down, I've got 2 zeros. I've got a 1 and a 1. So here I'm going to have to go across to the seconds. This one has 48 seconds. This one has like 0 seconds. It was on the minute. So this one is took shorter than eating breakfast. So cleaning dishes took shorter than eating breakfast by roughly 48 seconds. And then going for a walk, I can see going for a walk took 45 minutes. Recording a video took 2 hours, 35 minutes, 18 seconds, and 0.02 hundredths of a second. And there you go, it's that simple. So make sure when you're recording, you follow this format. It seems tedious, but it'll make it very easy to compare and you won't be making any mistakes. And that's it today, a nice short lesson. So the main ideas, when we're talking about duration of an activity, it's how long it takes for it to be completed. Hundredths of a second, that's the new unit of time we looked at today, which is the same as 1/100th of a second, and it's recorded with a decimal point. So here we've got 1 second and 29 hundredths of a second, so 1.29, and I've specified seconds here. And where there is a single digit or 0 for that unit of time, write a 0 or 2 zeros. So here this is, let's say it's hours, 15 hours. It's on the hour, so there are no minutes there. 29 seconds and 0.01 hundredths of a second. And lastly, which is the most obvious one, is a stopwatch is a useful tool for measuring time down to hundredths of a second, and sometimes it even gets smaller where you need to be super precise. All right, that's our 4th lesson for this week. There's one more for Friday. I look forward to seeing you there. All right, have a wonderful day. All right, everybody, we've come to our last lesson for the week. Today it's on elapsed time. So today we are learning to find elapsed time. And the first thing you'll need to know is, what is elapsed time? Well, elapsed time means how much time has passed. So how much time has passed between 2 points in time, for example. So let's say how much time has passed between 9 a.m. and 11:30 a.m. To do that, you'll need to calculate the difference between these two times, and you can use either a mental or a written strategy. So you can either do it in your head, or you can write it down on a piece of paper and keep track of it that way. Either is perfectly fine, whatever works best for you. We're also going to be adding periods of elapsed time onto a time. So let's say 9 a.m. plus 5 hours and 45 minutes. What would that bring us to? What would be the new time? And lastly, just checking our answer. So before I go into doing a few examples, I'm going to go through a few different strategies that you might like to use to keep track of how much time has elapsed between 2 points in time. Now, you might think, okay, I can already do this in my head. That's totally fine. Feel free to skip ahead. But if you'd like to see these strategies anyway, or if you're still a bit unfamiliar with it, kind of stick with me for this. So the first one is this T-chart strategy. It's really just putting into a table. So here's my start time. It's 8:26 a.m. And we want to get to 12:15 p.m. So we want to know how much time is between these two times. How much time has passed? So here I've written the times down here, and what I like to do with this one is bring it to a nice kind of round figure with time. So we know we've got hours and half hours. So I like to bring it to 8:30 here. So from 26 to 30 is 4 minutes, and I keep track of it on this side in the hours and minutes. Then I know, well, do you know what? It's still quite a way to go till 12:15. So instead of just adding minutes and minutes and minutes, I'm going to add some hours. Now I can't add any more than 3 hours, otherwise I'll go beyond 12:15, it'll be 12:30. So I'm going to add 3 hours, and that's going to bring me to 11:30. Yep, so I'm keeping track of it over here. Now I know I'm going to have to deal with minutes next, because adding another hour is going to bring me to 12:30. So I'm still going to bring it to a nice round number. So I'm going to bring it to the hour, which is 12 o'clock. And to do that, I'm going to have to add 30 minutes. So I've done that. And then from 12 to 12:15 is nice and simple. We know this is our minutes section, so I'm just adding 15 minutes. So here I've got all the elapsed time, and the only thing I need to do is add them up. Now I don't need to add hours because I've only got 3 hours here. So I'm going to add my minutes all together. So 30 plus 15 plus 4. Now I can do this all together or in parts, and I've done it in parts here. So I've added 45 plus 15, the big numbers together first. And then I'm adding the 4 on, so 45 plus 4 is 49. So my answer, the total amount of elapsed time is 3 hours and 49 minutes. That's our first strategy. Another strategy you might like to use is called this Zoom strategy. So I'm using the same times here, 11:26 a.m. to 12:15 p.m. Now I know 12:15 p.m. or 12 p.m. is midday, so it's not like in the middle of the night, so I don't have to go any further than that. But what I do first is I write my starting time here, and I kind of like to draw this shape, this kind of oval or whatever shape in the middle, and that's where I'm going to keep all the elapsed time. So here I'm going to bring this to the hour. So instead of adding the hours first, I'm going to bring this to 9 a.m. And I know that 26 plus 34 is 60. So that will bring me to the nearest hour, which is 9 a.m. So I'm going to zoom across this way. I'm going to put my 34 minutes in here. Now that I'm at 9 a.m., I know that 9 plus 3 is 12. So 9 a.m. plus 3 hours is going to bring me to 12 p.m. I've written 12 p.m. in a funny way there, missed out the zeros. So 9 plus 3 is going to bring me to 12 p.m. So I'm going to put my 3 hours here. I'm going to zoom down here. Now I'm at 12 p.m. Again, another 15 minutes brings me to 12:15 p.m. Then again, similar to the last time, I'm just adding up these times. So I've already got 3 hours, that's fine. So adding 34 plus 15 is 49. So 3 hours, 49 minutes. So you see the way with both of these strategies and with elapsed time, we kind of need to break it up into these parts and then add it all together. Sometimes it's nice and easy. We'll look at a few examples later where it's 7 a.m. to 9 a.m. Well, I know that I'm just dealing with hours there. 7 plus 2 is 9, so it's nice and simple. So there's only one step I have to do there, it's add 2 hours. But with these ones where it's a little bit trickier, where we've got different hours and different minutes going on, then we have to kind of partition it or break it up by using these kind of mental or written strategies. Either bringing it to the hour or jumping forward however many hours and then adding up the minutes to get to the destination time, which in this case is 12:15 p.m. And the last one is quite simple, and it's I've kind of done two visuals here. The first one is using a timeline. And this is just a great way of kind of keeping track of it. If you don't really like the table or the Zoom one's a little bit confusing for you, then this is nice and simple, kind of like a number line. We've got our timeline, we put our start time here, 11:26 a.m. Now here, I'm just going to add the hours first. Similar to, I think, the first one, I had 3 hours, brings me to 11:26. Then I want to get to the nearest hour, which is 12 p.m. So 26 plus 34 is 60. 60 minutes is the hour, so that will be here. So 34 minutes plus 15 minutes to get to 12:15, and voila, same answer. This is a strategy I found on the internet. I haven't actually used it before, but it's called mountains, hills, and rocks. And it's just another way of thinking about units of time and how big they are in relation to one another. So for example, hours are our biggest unit of time in the day that we use. So here I've got 3 hours, 1, 2, 3 to get to 11:26 a.m. Then the key is that intervals of 30 minutes, I think, and maybe even 15 minutes as well. Hills, I've just done 30 minutes, I like half an hour, so 30 minutes is a hill, and then the minutes that are smaller than that are rocks. So here we've got 3 hours plus 30 minutes brings us to 56 plus another 4 minutes will bring us to 12. Should have written that in. Plus 15 will bring us to 12:15. And there you go. And then we just add all of these up, and our answer again is 3 hours and 49 minutes. Okay, let's do a few examples. Now I'm going to kind of talk these through, so I won't be drawing them. If you need to write them down or record how much time has elapsed on a scrap piece of paper, feel free to do that. Feel free to try some of those strategies if you'd like to. Otherwise, you can do it in your head. Just make sure your answer is correct. So the first one is elapsed time. We've got 11:30 a.m. to 11:30 p.m. Well, nothing has changed here. These numbers are the same, but I know that p.m. is in the afternoon and that these two times are separated by 12 hours. Now, this is kind of where our 24-hour clock is actually really useful. It's really doesn't necessarily help us with the minutes, but it really makes the hours a lot easier. Here, nice and easy one, 7:30 a.m. to 7:30 a.m. to 10:30 a.m. The minutes haven't changed, so I don't need to worry about the minutes. Just need to, and also the AM hasn't changed either, so it's still in the morning. The only thing that's changed is this hour. So we've gone from 7 till 10, 7 plus 10, 7 plus 3 is 10, or 10 minus 7 is 3, so our elapsed time is 3 hours. Oh my gosh, I'm losing my words. Okay. Here we've got one that goes from 6:45 a.m. to 3:45 p.m. So again, the minutes haven't changed, but I'm jumping from a.m. to p.m. So I know that 6 plus 6 brings me to 12 p.m. So I might even just write that down here. 6 brings me to 12. And then 12 p.m. plus another 3 will bring me to 3 p.m. So it's 6 plus 3, which is 9 hours. That one's a little bit trickier though, because we're jumping between the AM and PM. We'll look at some 24-hour times now and show you how it's much simpler. It's one of the advantages of 24-hour time. So here I've got 24-hour time because I don't have the AM and PM notation. And I also have a 0 here as well, which is also one of the other giveaways. So 0300 hours to 1300 hours. Well, 3 plus 10 is 13. Oh, that looks like a 6. Apologies. 3 plus 10 is 13, so it's going to be 10 hours. There's no minutes changes there. So it's just 10 hours. Here we've got 8:32 plus 17:32. Again, what we're going to do is all of these ones are just dealing with changes on the hour. So 17 minus 8 is 9, or 8 plus 9 is 17. The minutes haven't changed, so it's 9 hours. So there are cases where just the hours need to be calculated because the minutes are still the same. So they're nice round numbers. Let's look at some trickier ones. Now those ones were nice and easy because only the hours were changing. Here we've got situations where the hours and minutes are changing. So let's look at 7:30 a.m. to 10:20 a.m. So still in the morning. And now I know that 7 plus 3 is going to get me 10, but if I do 7:30 plus 3 hours, it's going to get me to 10:30 a.m., which is too much. There's two ways of doing this, or there's actually more than two ways of doing it. What I could do is I could say, okay, fine, let's add 3 hours, which will get me to 10:30 a.m. And I know that 10:20 is 10 minutes less than 10:30, so I have to take away 10 minutes. Now I know that there are 60 minutes in an hour, So I'm going to keep it 2 of those hours, and that last hour I'm going to take away 10 minutes, so it's going to be 2 hours and 50 minutes, because I had 60 minutes on that last hour, I took away 10 minutes, now I have 50 minutes. It says 50 meters, I want 50 minutes. The other way to do this is to go, all right, so let's go, I know that adding 3 is going to get me to 10:30, which is too big. So I can say 7:30 plus 2 is going to get me to 9:30, plus another 30 minutes brings me to 10. So let's say, let's keep a record of this, 2 minutes, also 2 hours, 30 min. And then, so I'm at 10 o'clock now, and I need to add another 20 minutes to get to 10:20. 30 plus 20 is 50. So 2 hours and 50 minutes. So that's another way of doing it. You can either kind of go backwards by kind of going to 10:30 and take off the 10 minutes. Otherwise, you can add the 2 hours, then add another half hour to get to 10 o'clock, then another 20 minutes to get to 10:20. Now, I've kind of made a little bit of a mess of it over here because I don't have a lot of room. But you can use those strategies I showed before by keeping it on a table, or just kind of keeping some notes on a piece of paper next to you if you need. If you can do it in your head, that's great. But it's really just sort of breaking it down either, and it's completely up to you. Some people prefer to add the minutes to get to the hour. Some people like to add the hours to get to add as many hours as they can, and then add the rest as minutes. Here we've got 8:45 a.m. to 11:17 a.m. So again, I know that 8 plus 3 is 11, but that's going to be too big. So I could do that way of making it a 11:45 and then subtract to get to 11:17. But I'm just going to do it the other way today. So and what I'm going to do today, just to make it a little bit easier on myself, I'm going to add the hours first. So I'm going to go, actually, I'm not going to add the hours first. Let's do it a little bit differently. Let's say we add 15 minutes to get to 9 o'clock. Then I'm going to add another 2 hours to get to 11 o'clock. Then I'm going to add another 17 minutes to get to 11:17. Because we're still in the AM, so that's correct. So here I've got 2 hours. Then I need to add these two together. 15 plus 17 is 32. So it's going to be 2 hours and 32 minutes difference. Here we've got 5:32 a.m. to 3:57 p.m. Now this one, because the minutes here on this time are larger than this time, I can add the hours first and then add the minutes to get up to 57. Whereas in this case here, you'll see the minutes from the start time are larger than the minutes at the arrival time. So it's I find these ones a little bit trickier than this one. So here, I've got to keep in mind though that I've got 8 a.m. to p.m. and we're all assuming this isn't the same day. So to get to 12 o'clock, to get to 12:32, I add 7 hours. And then I add another 3 hours. So let's say 7 gets me to 12:32 plus 3 hours will get me to 3:32. So this is our hours. And now I need to get from 32 to 57. So I plus 25 minutes. And you can break this up however you like as well. I just knew that calculation in my head. But basically, you're finding the difference between 57 and 32. Then you're just adding them up again. So here, 7 plus 3 is 10, plus 25. So we've got 10 hours. Let me try with my pen. 10 hours and 25 minutes. And the last one here. Now, this one, the 11:56, this is very close to the hour. So I'm actually going to round it up to the hour. So I'm going to plus 4 minutes, which will get me to midday or 12 p.m. I'm going to put 4 minutes here. And then I just need to add, I'm at midday and it's 7:34 p.m. So I just need to add 34 minutes and 7 hours, because that's telling me that's 7 hours and 34 minutes after post midday. Then I just add these together. 34 plus 4 is 38, so my total is 7 hours and 38 minutes. Now that's finding the elapsed time between 2 points in time. Here we're adding elapsed time. It's very similar. Let's do it together. So here we've got 3:32 p.m. I'm going to add 18 minutes to that. So I'm going to do my ones first. So it's going to be 3:40, because 32 plus 8 is 40, plus another 10 is going to be 3:15 p.m. Sorry, not 3:15 p.m., 3:50 p.m. That's better. Here we've got 9 a.m. plus 1 hour and 45 minutes. So now, instead of just changing the time within the hour, we're adding hours and minutes. So we're going beyond the hour, and we're also adding some minutes. That's nice and simple. 9 plus 1 is 10. So it's going to be, the hour is going to be 10. And the minutes are going to be 45. And we have to write out AM as well. 11:30 a.m. plus 3 hours and 20 minutes. For this one, I'm going to add the hours first. So I get 1 hour will get me to 12:30 p.m. plus another 2 will get me to 2 p.m. and 30 plus 20 is 50, so it's going to be 2:50 p.m. All right. Second last one, we've got 8:35 a.m. plus 2 hours and 25 minutes. For this one, again, I'm going to add the hours together first. So 8 plus 2 is 10, so we're still in the AM, 10 a.m. And we're at 10:35. 35 plus 25 is actually 60. So instead of saying within 10 a.m., I can't have 10 hours and 60 minutes. That just doesn't make sense. Yeah, that's going to be 11 o'clock. We've got enough minutes to make another hour, so it's going to be 11 a.m. And our last one here, 5 hours, oh, sorry, not 5 hours, 5:22 p.m. plus 4 hours and 20 minutes. Oh. I'm going to add the hours again together. So it's completely up to you. You could add the minutes first. I prefer to add the hours, just a preference. 5 plus 4 is 9. So it's going to be 9 p.m. And the minutes, I just have to add them together. 22 plus 20 is 42. And there you go. That's adding elapsed time, or adding time onto a start time to get, what's the new time that we're at. And that brings us to the end of our lesson. So here are the main ideas from today. Elapsed time is just how much time has passed between 2 points in time. So how much time has passed between 10:15 a.m. and 3:42 p.m. To find the elapsed time, you can use written or mental strategies, or a combination of both, whatever works best for you. So look back to those strategies earlier on in the video. I'm happy for you to use whichever ones you want to. You can record it on a piece of paper. Adding to get to the nearest hour is a useful strategy, especially where the start time has more minutes than the end time. So for example, 8:47 a.m. to 10:12 a.m. Adding to get to the nearest hour to get to 9 a.m. is kind of the 9 a.m. whatever it was, is the better, easier way of doing it, rather than having to kind of subtract. You can do multiple operations. But whatever works best for you. If you're kind of flexibly minded like that, that's totally fine. And lastly, to add elapsed time to a start time, it's basically using the same or similar strategies to what you use to find the elapsed time between 2 points in time. Now, in your worksheet today, you'll have some analog clocks and you're finding elapsed time there. If you have some difficulty reading an analog clock, focus on finding out what that time is first, and then maybe write that down somewhere or record it in your Google Doc. So you're not kind of doing two skills at once. You're not kind of trying to read the analog clock and then trying to find the elapsed time. First, find out what the elapsed time was on the analog clock, write it down, then you can do the elapsed time part of the activity. Okay, thank you very much for your attention this week, guys. Have a wonderful weekend, and I'll see you next week. Bye.